Hello. Welcome, gamers. It is, in fact, Monday. And we are back with Monday. That's right. Once again, it is Monday. And this is going to be a game developing stream. And specifically, it's going to be Picross. We're going to make Picross on the Game Boy. I've already started this weekend. Let's learn about this picture. It's real, okay? It is a place known as Sri Lanka. It's Sigiriya, a rock fortress in central province, Sri Lanka. Though this scene, reminiscent of The Lion King, is actually set nowhere near the savannas of Africa, it's something. I can't see what it says because I'm blocking it. Its grand granite subject bears the name bears the name Sigiriya, or Lion Rock, and like what? And what do they mean? And like, I guess we'll never know. We will just never know. Anyway, welcome Stream Elmos, welcome Denchi, welcome Votato, welcome A Pullen, Slime Molder, Stanley. How did they get up? You can see right here. There's like a path, maybe. Maybe they climb. Maybe they get the ability to climb. They can find the cake or whatever. I don't know. There's some options. And look at this. We got today's image. It's Picross. That's right. A 5x5 Picross. The simplest you will ever need. The shrimpless. It's actually so shrimple you don't even know. Anyway, for Game Boy though, I've made sure that this can work on Windows. I've been developing this on my Mac, and I've been programming various things, and it worked today. It worked. I actually got it to work. Okay. So this is actually, okay, this is also the stream ending song, which is not actually happening. I'm gonna skip this song. This is not using GB Studio. As you know, GB Studio is a thing that you can make Game Boy games. But Picross is actually, surprisingly, a bit too complicated. Even with a custom engine. Do you know, this is like a thing that you don't really think about. Also, welcome ChocoJax. You don't really think about this, right? If you play Mario's Picross on the Game Boy, you're like, oh, it's just a grid-based game. It's so easy, right? It's literally so easy. You just make a grid. I've talked about this on one of the lawn mowing sims. However, before I knew how the Game Boy memory worked, I was like, it's probably easy, right? No. It's actually, they had to do a lot of very complicated things to get this to work on the Game Boy. They actually use interrupts to make sure that after this line you render using a different tile set. Note how, okay, so on the Game Boy, tiles are 8x8. You'll notice this one though, if you tried to fit 8x8 on a 15x15 board, it would not fit on the screen with the numbers. These are actually 6x6 tiles. And thanks to Mai for downloading Emulicious like I told him to that one time on stream, and he showed what the memory looked like. I'm gonna copy the image URL here, and I'll show you. Okay, Emulicious is a Game Boy debugger. Also, welcome Zoli. It'll show you what things look like in memory, right? This is a 5x5. They have the entire puzzle in here. This is all the assets, right? It's like, you know, whatever, it's fine. But then you look at a larger one, such as this one right here. They put the entire thing as tiles, and these don't fit perfectly. Okay, as you're updating things, they're updating the memory with the tiles. They have to do like some complex logic to map like the tile position to like the actual tile in memory, and then you gotta like update multiple tiles because, you know, it might not fit in one tile. You might have to update 4 tiles at a time to make one change. And then okay, this is the updated one. When they have filled stuff in, it looks like this. This is in memory. Okay, you'll notice here at the top they have the numbers on the top, And they have the numbers on the left side. This stuff right here, this is the left side. This is like this section right here. They put this in this memory. And okay, here's one thing you got to think about the Game Boy, is that it has 2 addressing modes for tiles. You don't actually have enough tiles to fit on screen at any given time if you're trying to like include the top and the bottom. Because actually, I think the default tile mode, you can only have this many tiles. Actually, let me look up an explanation for you. GB Studio, this is going to be about GB Studio, but it's going to apply in general how the VRAM works. I have to say I didn't actually understand this when I posted. It was in response to on stream. If you were there, you would have known. Okay, so let's see. This one, where do they talk about VRAM? This one. I was there. On the stream, though? Maybe you were. So this is how the RAM works. Okay. You have 2 different sections in memory. This top one here. This is specifically mostly for sprites, but you can also put tiles there if you use some clever strategies. But by default, tiles can only go from here to here. They start off here and they increase, and then after that they go here and then they go down, right? So the way they laid it out in memory is very strange, but they got it to work somehow. But then when you're like loading things into VRAM, you got to consider like, you know, this stuff, and then you can switch tile addressing modes to be able to use the top one for tiles instead of sprites. So this is what they did here. I didn't understand this when I was implementing this. I was like, oh, they probably just had these as sprites on the screen. You're allowed to have a maximum of 40 sprites, and like that seemed like it'd be enough to show this, right? And also some of these stuff. But then I read a thread that was actually like, oh, actually, they're not actually using sprites. They've programmed interrupts so that on the Game Boy, it draws things one line at a time, right? So you can draw the top one using these top tile sets, and then once it reaches this point, you switch a value in the register to change the addressing mode to point to the bottom one, and then that's how you can have mixed tile sets. And then you can draw the stuff on the bottom with the bottom one. It's actually absurd. And this is stuff you don't think about. You're just like, it's just like a grid, you know? It's like the simplest thing you can possibly do. It's so easy. But no, it's not. And I've implemented this, okay? I've created a Bazel project. Specifically, how do they do the numbers on the bottom? This stuff is just in memory, I guess. It's rendered the same as this stuff. But it's like when they load the level, you can update the values in memory. So you can do like a bit mask, say like this one's 1, do like an and then change this thing, I don't know. Stuff like that. But I have this repo set up. It's not using, what is it called? GB Studio. It's entirely from scratch using the GBDK, which is a library you can use. It'll define some functions you can call, but then I was like, I don't want to like have to manually set up GBDK anywhere. So then I built a Bazel project. Bazel, if you're not familiar, is a way to cross-compile different languages and things like that. You define rules. So I've defined a tool chain that will download GDBK for your relevant platform. Actually, it's LCC. GBDK provides a compiler. It provides the SDCC, not San Diego Comic-Con, but the Small Device C compiler. And they have a wrapper around that called LCC, which you can use to call the different tools. I've defined all this stuff here so that you can use the regular Bazel C library build setup. I had to override a few things just to get it to work, but it works nicely. It can compile things. I have it so that I've set up dependencies, so if I change a file in ASprite, it'll generate a PNG, and then that PNG will generate a C file, and then that C file will be included automatically. It's actually pretty nice. Let me show you my A-Sprite files. I mean, how do they do the crosses and the open tiles? They just set the right tiles. Yeah, you just change the values in memory. What was it called? Game Boy docs. What was it called? The docs? Pan docs. So they have. Okay, I'm going to explain how tiles are set up in memory. Okay, we have VRAM. Is this it? No. Where did they do it? Summary graphics. Tile data. Okay, so they set these things at different memory addresses. This block right here corresponds to the top. This block right here. Right, and then they have block 1 is this one. And these are simply indexed in memory. They have bytes. This is how it's represented, in case you were wondering. Every pixel is represented by 2 bits. They have, since there's 4 colors on a Game Boy, you can represent that as 2 bits. And they have like one byte. It's called 2 bits per pixel or whatever, 2 BPP. And then this is how it's laid out in memory. You have this thing next to this thing. So these are the values, and then they combine together to make the colors. Right, and if you want to change the value at runtime, you just access some offset from this position, and then you'll just modify the bits to be whatever you want it to be. There's probably some more advanced stuff you have to do, like making sure that it's actually loaded in VRAM. You gotta wait for some signals or something. But yeah, you can modify things dynamically. That's how they do like text stuff. You'll notice in GBDK, they not GBDK, what's it called? GB Studio. They when you're writing text to the screen, like this right here, GB Studio reserves this part for text, and they're simply copying the bits from ROM into VRAM, and then this tile gets shown on the screen at a certain point. So you can dynamically change stuff, and that is presumably how they do these numbers. Like it starts off like this, and then as the level loads, it just puts the numbers in. And then when you're making changes, it just, I don't know, it just modifies these things as well. You'll notice, you know, you can set this to 1 or 0 or whatever. But that's there. Anyway, this Bazel setup here. We have set up various things. I didn't actually know like anything about compilers or linkers. I don't usually work in C or C++. But, you know, how it works is that you have a compiler. You actually have a what's it called? A preprocessor, which will handle all the like pound include symbols or whatever. That'll process stuff. Then it'll send it to a compiler, which takes a .c file, converts it to an .o file, an object file. And then that eventually gets grouped together with other .o files to make, well, in Game Boy it's a .ihx file, but then GBDK has a thing that converts this thing to like a .gb file. The .gb file is the actual ROM that you can run on your Game Boy, and that's how it works. And actually, since we're using LCC, we have to pass through a bunch of flags to how to get the dependency files. Bazel actually has like this requirement that everything has to use like, I didn't really know what this was. It kind of generates a dependency file that tells you what your source files depend on. Stuff like that, I don't know. Back in the day, you had to use a locator to manually locate the sections. Yeah, I don't know about any of that stuff. I just modified some code that I saw. And then, you know, because the GBDK stuff doesn't handle things in the same way, you have to like do this stuff. Added a verbose flag. Whatever. And then after you compile it, we have custom rules for A-Sprite that I've defined. Because I didn't want to have like go into A-Sprite, manually click, like export this thing as a PNG, and then like run a script to convert the PNG into a C file. Welcome, Altscott. I wrote some A-Sprite rules. I did not know anything about Bazel toolchains, but I got it to work. You basically define platform-specific config. So in ASprite, I have it set up here. If you're running on Mac, it'll do this stuff. If you're running on Windows, it'll do this stuff. On Linux, it'll do this. So it works across different platforms if you have ASprite installed. If you don't have it installed, this is not going to work. If you have it installed in a different place that's not the default, it also doesn't work. I probably should figure that out. But at the moment, it has to be in one of these places. And then we have some GBDK custom rules. There's one called PNG to asset. This is probably like a lot of information. You're probably just like, what is he doing? Can you just show us the game already? No. It's necessary to go over all this stuff. Okay, so then the PNG to asset is a tool that will turn a PNG into a C file. Now, if I show you my setup right here, I'm going to open up ASprite. I'm going to go open, welcome Craig. Okay, where's my files at? I don't even know where these files are. I probably should have saved these at a better place because, you know, I'm using Windows subsystem for Linux and it doesn't really map over that nicely. Let's see, where is it? Does anyone know how to find out where this is on Windows? I probably could have done this before the stream. Let's see. Windows subsystem for Linux, how to find directory in Windows. It's in /WSL. Okay, we're gonna go to this one. I'm gonna do, how do you do it? You do slash, is that 2 backslashes? WSL localhost Ubuntu. Paste. Oh, that was not it. What was that? That is not the same thing. What is that? WSL localhost. Alright, whatever. Imagine that I showed you an ASprite file. Right, it would convert this. Actually, let me just show you. We're gonna go here. We're gonna go Bazel build. We have our build file, which specifically has these. Okay, so I have a bunch of files. I have nonogram bottom and top and sprites. So I'm gonna run the emulator. I'm also downloading an emulator. That's right, I didn't want to like manually download an emulator. I have set up some Bazel rules to download Emulicious, so whatever platform you're on, it'll download, it'll build the thing, it'll run it. This is what I've built so far. We have this, we're rendering the top, we're rendering the left side, we're rendering the grid. There's a way to see the memory. So this is the tile map right now. Everything is set up in memory. We have the tile viewer. This is how it's set up in VRAM. It may look very confusing, and that's because it is. It doesn't match the way that the Game Boy does it, or the Mario Picross does it specifically, because it doesn't work as well in memory. But this is the top part. So you'll see here, this one corresponds to this point right here. Everything's here. Welcome Wed. And then you can update these in memory, and they should theoretically be updated here. This stuff corresponds to the stuff at the top. And then we have these are actual sprites. This is our cursor sprite. I copied this directly from Mario Picross. I will probably change this at some point, but for now I'm just using this. So that's there. That's in memory. And then we have other stuff. Sprite viewer. These are the sprites. You'll notice that I also have like a little animation. It's very subtle, but you'll note this changes color. It's not just black, it is black and then it becomes a grayish color. So that's there. So how does this work specifically? Well, good question. I'm gonna build assets. We're gonna have assets, sprite. So there's two different types. We have the grid for nonogram, and we have sprites.asprite. Oh, I also have it set up so that it'll export the tags from asprite. So we have assets, nonogram, grid. Sorry, Basil build. So it'll take my input asprite file, which if I could show you, that would be cool, but I can't show you because I don't know how to open it from here. Actually, is there a way to open? No, alright, never mind. So it'll take this asprite file, it'll take these tags from the file, and then it will export them. An important thing you gotta notice is that we don't optimize, because if you optimize it, it'll compile, or not it'll compile, it'll take the similar tiles and put them together at the same place, which is not what we want. Because we actually want it to be, wait, oh, here it is. I have actually opened it. Okay, where is it? Got user, home. It's in home, Wolfie, code, GBDK example, and then, okay, here we go. Okay, so this is the top. We have 3 different sizes. We have 5x5, 10x10, 15x15. And then we have nonogram bottom, which is a very similar thing. You have the 3 sizes. And then on the bottom, we just have like a few like different tiles for other stuff. I'm probably gonna make this so that it's gonna be like in Mario Picross, where we have like some stuff on the left side and the right side and the top side and maybe this stuff as well. But for now, it's just like this, right? So the thing will go through this file, it'll export all the tags, and then it'll run this script, PNG to asset. And that thing takes a PNG file, and it actually generates a file that looks like this. Can you have a Wolfie sprite at the top left? Probably. So it generates a header file. Is this a header file? No, this is a C file. But this has the bytes, as you can recall from here. This is the byte data representing the graphics from here. So it goes on for a while. And then they have a .header file, which will give you like different counts. It'll tell you the number of tiles. And then, let's see. And then what? And then what? What am I doing? Welcome BrainZap. Got Basil, bin, assets. Okay. So we'll generate these. And then it also has, yeah, it has the sprites, which is slightly different. Sprites.c. So this one, I didn't even show you what the sprites look like. So the sprites has a slightly different format. This is the cursor. It has two frames. And the way that PNG to asset handles metasprites, okay. Metasprites is a totally different thing. A metasprite is composed of one or more regular sprites. So if I run this, and I show you what the sprites look like. A sprite on Game Boy is either an 8x8 tile or an 8x16 tile. And the way that this works is, if you set it up in 8x16 mode, like this, welcome Nutritious, it'll group these two together. So that you address one thing and then the thing directly after it is part of the same thing. Now a meta tile is when you combine one or more tiles together. So you'll notice this sprite is actually made of 2 8x16 tiles. Right, and then the whatchamacallit, the PNG to asset tool takes your PNG. You tell it how big your meta sprite is. So in mine, it's going to be 16x16. This will have all the sprite tile metadata. So it's going to be like, okay, load this in memory like this. And then it generates your meta sprites. It'll say, okay, the first sprite is composed of 2 sprites. Sorry, the first meta sprite is composed of 2 sprites. It's composed of the left thing and then also the right thing. You'll notice that also it didn't make another version of this. It's because PNG to asset actually deduplicates tiles. So that's why, like, if you have this tile is actually the same on both of them, they can just reuse. They can point this thing to this thing. So yeah, you'll have frame 1 is this one, made of 2 sprites. This one is also made of 2 sprites. And then in my actual code, you're like, Wolfie, where's the actual code? You've just shown us build files. We have nonograms.c, which has a bunch of stuff. A lot of bit shifting logic going on here. You can ignore this stuff up here for now. We have main, which is our, our main thing. They have a bunch of macros. You can define, you set up sprites, show background. And then I have it set up so that we load the tile size based on a variable. And so if I change puzzle size to like 10, and I rerun this, it loads an entirely different set of tiles. Actually, I think I did it wrong. That's 10, that should actually be... Okay, I found a bug. I did not change this. It should now be changed. I fixed a bug live on stream. I've successfully done something. Welcome, Deffins. Okay, that's a 10 by 10, right? It's been done. So what that'll do, we have this set up. We have pointers to different tile counts, other stuff like that. We copy the variables into VRAM. We also set the color register. This is a different thing. If I don't set this, it's going to look slightly different. You'll notice the cursor here is actually dark. The way the Game Boy does colors is that it has palettes. We have, this is actually, there's a forum thread that I copied this from. But everything has 4 colors, as you'll remember from this. It doesn't have to be that 0000 is dark. You could set this to be like the light color. You could invert stuff. That's actually how they do fading on Game Boy. You'll notice in a lot of Game Boy games when you switch scenes, there's like a fade in, fade out effect. They do this by just changing the palette so that the colors become darker. So like color 1 is like dark regularly, and then when they're fading, they set color 1 to be like slightly lighter, and then the next frame they set it to be even lighter, and then they set it to be 0, and then they change it back. But it affects all the tiles in the scene. Also, welcome Old Man Diabetes. But yeah, that's how that works. And then, okay, then we're going through every tile, checking the position on the screen, and then we're incrementing some counts. So the way this is laid out in memory, right, you have these, hold on, let's find the tile map. This is the tile map, right? Every one of these tiles. Also, the thing about the Game Boy is that there's actually more space than what fits on screen. It has scrolling functionality built in, so you can draw stuff that's outside the screen, and then you can just scroll the window over to it. For picross, you don't really need that, because we're just like, everything fits in this one window. But if we're making like a platformer, if you're moving to the right, you could maybe like draw things that are about to be seen and then move the window over. But we don't need that. So for this one, we have, what was I describing? Right, I was going through every tile and then setting it based on its position. So if I copy some of this stuff out of here, so this is the one that checks if you are in one of these top tiles, right? It's drawing this stuff. If I remove this and I rerun it, it actually, like it doesn't draw the top tile. If I remove this one, it doesn't draw the bottom tiles. Right, so that's how that's set up. At startup, we just iterate over every tile. We set the tile to be the specific one we need. If it's not any of these, we set it to the default background tile. And then there's this stuff. This stuff is actually when you set up the interrupts. So if you'll remember before I explained that on the Game Boy, everything uses one set of addressing modes for tiles. If I did not have this code in here, it would draw the things with the same tiles. So if I removed handle scan line, you'll notice that I actually use the same tile numbers for top and bottom. You're like, wait a second, how can you have the top tile be 1, 2, 3, but also bottom tiles references the same one? This is the thing that I was talking about, where in Mario's Picross, they set up an interrupt so that after you're past this point of the screen, they start drawing with the different addressing mode. So if I remove this stuff that handles scan lines, and I rerun it, you notice the top part, it actually, I guess it just crashes, I don't know. Okay, what if I take the handle scan line and just don't do anything? Right, you'll notice the top part is like garbled, it's like a mess. It's because these are actually referencing the same tiles in memory as the bottom one. Right. This stuff is pointing to... Actually, you could even look at this. If you have these windows open, you could be like, okay, which tile is this one? This is tile number 1. Right, if I hover over this here, you'll notice this thing also gets highlighted. So this corresponds to like these tiles, which is wrong. But yeah, it's messed up because we're drawing with the same tiles. If I put the code back, you'll notice it looks right now. Welcome Xjob. And yeah, that's because we draw numbers. Every scan line we draw, and then we switch over. If I change the number, for example, tile switch scan line, if I change this like, 30, and I rerun it, look at that. It'll drop to here, and then it'll switch to the other addressing mode, and then it'll take the tiles from the other set. And so it's actually like amazing. It's like, what the frick? How did they think of doing this back in the day? They just like get picross to work. You have to like do like interrupts handling, you have to like deduplicate tiles in memory, switch addressing modes, set the grid to be like not 8x8. You gotta like do some bitwise operations to get the numbers showing up. But yeah, so that's there. And then what? And then I have inputs. This one's pretty straightforward. They have a function joypad, which I think just returns a byte value. And every field in the byte value corresponds to like, this could be like left button was pressed. This one would be like right button was pressed. I don't know. It's not exactly this, but something like that. And you just check what's pressed. I have a variable to store the current cursor position. So it starts at 0, 0, which is the top left. And then you wrap around. I probably need to add something nicer for this, because I know when you're playing Picross, if you hold right, I think normally it stops on the right edge, and then you have to like press right again to get it to move. This is also a bit too sensitive. Do you know that the Game Boy runs at 60 frames per second? It's actually very impressive. Anyway, yeah, you want it to like hold it until it hits the edge, and then you press it again to like wrap around, I think. I think I probably should like replay Mario's Picross just to see like what the controls are like. Just to make sure I get like the look and feel correct. Because like I've played some Picross games this past weekend on Pico 8, and there's like things that were not correct. I mean, they were correct, but they were a bit annoying. Like in Mario Picross, you can hold the A button and then move right to mark tiles. But then in a lot of games, it was like you have to press A for like every key, like for every thing you want to mark in. It's a bit annoying. I think they got it right for Mario's Picross though. Anyway, so we have movement, we have... this is where I handle the frames. It's the very subtle animation where the this thing changes between black and like a light gray. Actually, I can't even really see it. No, yeah, look at that. It's changing between black and gray. And that's done here. So I have a variable that stores the timer, your current frame. Every frame, we update the value. And then we get the frame, we do a bunch of like, this is basically division. And then we get the frame, and then we draw the meta sprite. Okay, the way that sprites are handled on the Game Boy. GBDK has a thing called meta sprite, which I've explained. But what this is, when you call move meta sprite, you give it the meta sprite that you want to draw, and then you want to give it the offset in memory. You'll note that here we have it set up so that the thing that's in our file like assumes it starts at 0, but you gotta set like the specific offset. So I personally know that I've uploaded the top part of the grid to these memory addresses, and I happen to know that this sprite starts at this address. So that's why I pass in nonogram top tile count here, because that's the starting index. And then sprite index, every time you call this, it'll return a value that represents how many sprites were drawn. You're only allowed to have, I think, 40 sprites on screen at a time. And so as you're changing stuff, this value sprite index will increase. And then you got to remember the most recently drawn sprite so that you know to increment that counter. Every sprite has an ID. And this is what it's doing. It's drawn 2 sprites to the screen. This thing gets increased by 2 every time. If I had like another sprite to draw, sprite index would be increased by 2 again, assuming the sprite took up 2 sprites. And then you give it the X and Y coordinate. And you'll notice this +8 and +7 here. It's because this thing, I think meta sprites by default start in the middle, but then I set it up so that it starts in the top left. And then you'll notice that this tile right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's actually 10. I don't know like why I have this set up here, but I found that these values worked for some reason. And then +7 for some reason. Welcome props on Jack. What's picross nonograms? Logic paint, that's a different thing. Yeah, while one. So there's wait VBL done. Waits for a V blank. So every frame there's a V blank signal, I think, that gets sent. And you can, this one will wait until that signal is sent, which means the next frame is about to be drawn. So that's why this thing, if you don't have this here, it'll just loop without waiting, which is probably not what you want. Maybe from the bottom, but that would be 6. Yeah, I don't remember exactly. It's probably something, I don't know. we have these numbers here. I think this 58 is simply just the pixel offset where this thing starts. So this is like 50, this is 58, and then 50 is like here. So it should be this coordinate here. And then we have, I added 8 for some reason. Actually, where's this one? Maybe it starts from here. Maybe I have the numbers wrong. I don't know. But the 7 is there for some reason. Wait, maybe it starts in the middle. Is that what it is? 1, 7. 7 is actually here. So what does that mean? What does that mean specifically? I don't know. But, you know, that's something. So I've pretty much explained, I think, everything that you need to know about what I've done so far. Now you can be like, whoa, that's so cool. You built a cool thing that does stuff. It does signal handling. It was actually very cool. I was like, man, I didn't know. I didn't know how complicated it would be to make something for Game Boy. Because, like, if I play other Game Boy Picross games that are made by, like, not Nintendo, you notice they probably don't work for 15x15. If I, like, go to, like, this game, for example, the Picrosses are, like, 4x4 or 8x8. Or 12x12, which are unusual sizes. But I understand why they did this, because they have everything as an 8x8 tile. And then there's like another one, Game Boy Picross itch, which I think also only goes up to 10x10. Aren't your sprites misaligned? By what? Like this? Misaligned. What was there a Mr. aligned? All this is giving me flashbacks to when we had to implement VGA on FPGAs. Signal timings. Exactly. There's a lot of like hardware stuff you got to think about. It's like fun because I feel like if I was just making a picross game, like not on the Game Boy, it would just be like, oh, okay, just draw like a bunch of squares. But this is like, oh man, this is like you get to learn about stuff. The boxes are 6x6, yes. Yes, they are. What was I doing? I don't know. I was looking for some other picross game, but I can't find it. As far as the encoding for puzzles, I think I'm gonna do it similar to the way that this stuff is handled. I'm just gonna have it like literally be the same format as these sprites are in, so that I could just like draw them in some art program and then export them as a C file. And that means that each byte is gonna have a little bit of wasted bytes, but that's fine. Yeah, you could run it on a real Game Boy. So I was thinking like for a 5x5, you'll have 8 bits per byte, right? And then you could draw them in some program like ASprite. You could be like, okay, this is like a table or whatever. I don't know how a table works. But then, you know, there's more than 5 things here. But then I guess like these things will be wasted. This will be wasted space, but that's fine. You're gonna do this, right? This is gonna be the layout in memory. And then if you have like a 10x10, it's gonna be like this. And then you're gonna have another set of stuff down here. So 10x10, you know, you could go up to here. You're gonna be like, it's gonna be like this. And you could quite easily just draw this to the screen because it's using the same format as the Game Boy would draw stuff. So you could just copy this tile over to memory somehow. And then like for a 15x15, it would go up to here. We would have one thing on the right side that's missing. There's various things you could do. I've been thinking about these all day, decided to just try them all. I've thought of this one. You're gonna make a picross as well? I think that'd be cool. But yeah, you could represent things in memory like this. This is the 1 BPP format. Game Boy. 1 bit per pixel. Is there a diagram about this? Anyway, that's something. I was thinking like if I do it in this format, I could also like draw it in different colors. Like I could have 4 colors and then say like the black gets turned into like tiles here. Right? If I made it so that it was like this. Let's say I wanted to like draw a picross puzzle. I could simply I could go here and be like, okay, we have a grid settings. We have an 8x8, and then like if you're doing a 5x5, let's do like a 10x10, right? A 10x10 would go up to here. And then I could be like, I could even use other colors. I could be like, okay, this one. You know how like when you play Picross and you solve the puzzle, they'll show you like an image of what the final result looks like. We could use the black specifically for things that you have to solve for. And then like when the full image gets revealed, you can like use this stuff to show the details. You could be like, oh, look at this. This is like, I don't know, like a toaster or whatever. Let's say this is a toaster, right? We'll have these as the solutions. And then like this stuff is just decoration, right? You could have like some stuff over here. Have something else. I don't know. Just an idea. You could draw it in whatever program, and then you import it as a C file. And then it'll generate like this data for you. You could just compare in memory. I'm doing it in Rust because I want to learn Tokyo. But why do you need Tokyo for Picross? Are you gonna use like a... What are you gonna use to display the graphic? Is this just gonna be like on the terminal? Multiplayer online. Graphics, are you gonna use JavaScript? Oh, you're doing like WebAssembly stuff? That's crazy. There's a thing called MacroQuad. It's like a game library you can use to draw shapes. Welcome Alpha 333333. I don't know, whatever. Anyway, Game Boy. Isn't that cool, Game Boy? Now you understand everything you need to know about Game Boy. I can't even talk. I think it's very cool. I think it's cool that you can still make stuff like this nowadays. Okay, I've changed a few things. We changed the puzzle size. Let's change that back to 15. Welcome Honktown. I've changed, oh yeah, this, okay, I have to change this. The jar is actually, the file is actually uppercase E, but I guess on Linux it's case sensitive. So I needed to actually commit this. Fix malicious jar capitalization. Capitalization. Yeah, case sensitive file systems. It worked on my Mac because it's case insensitive. And then it didn't work on Windows, and I was like, what the frick? Or Windows under Linux, I guess. Anyway, so this works. What I'm doing today, though, I'm going to try, I guess, to figure out how to draw numbers, or like, I don't actually know what I'm doing today. I'm going to do something. So we have the grid that we've drawn. The grid has been drawn. I guess I could today, I could build something that will render. I don't know, maybe what I should do today. I should have it so that if you press A on something, it'll like mark the position. Because that's something I'll need to do eventually anyway. It's probably it. Factorial mods can run from a folder with the paths being interpreted by the same, but when the mod is archived, the address case sensitive, result in weird Heisenberg. Yeah, a lot of subtle things like that. Anyway, but yeah, we have this. So we can move around. We have the current cursor grid position stored. I could have like an array that is your current marking solutions. So let's think about this, right? The example I had. So we have I guess we don't have to use bytes for this. If we know the max puzzle size is going to be 16 by 16, sorry, 15 by 15, we can always allocate a 16-bit value, which corresponds to one row, right? So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have this. This is one 16-bit value. This is another one. And then we just have 15 of these. I guess we could have 16 just to make it round nicely. And then, okay, and then every one of these is going to be, if it's 1, the player has marked this. And then you're like, okay, but what about when they mark, like, you know, an X? You know, sometimes you mark where the thing is, sometimes you mark that it's an X. I guess we can have, like, a secondary array that is, like, what they marked? I don't know. I guess there's 4 states, okay? 4 states, it's empty. This has been marked. 1, 0 could be like, what do you even call it? Temporarily marked. Like when you think it's there, but it might not be. And then 1 could be temporarily marked. Well, okay, you mark it as not there as an X. Right, these are the 4 values. Is there like another value? It's empty. It's marked as being there for sure. It's temporarily marked and marked as an X. I think that's all the values. So we could have two of these. Right, so then you'll take the value from here and the value from here. Unmarked, empty, full. Okay, we have full. That's like when you're playing and you mark something in like yellow or something, because you're like, I think it could be here. Marked. I don't know what a good name for this is. Just like empty. Empty, solid, maybe. X and transparent. I don't know. Oh, but do you also need like another one for like you mark it as it possibly being an X? Wait a second. But that was only really in Mario's Super Picross, right? They had the question mark mode where you could like mark stuff optionally. That would be like its own thing. But I feel like most Picross games don't have this. If you're marking it as an X, it's not like a temporary thing. It's like permanent. I don't know if we need that. Is that a thing in Mario's Picross on the Game Boy? I guess they don't like. You play this on a regular Game Boy, which doesn't have color. Did they even have the marking mode? Or you could say it might be there. Because when I played it, I don't think it had that. Did it even have a Wario mode? I guess it probably did. I don't know. But this is how it's laid out in memory. Okay, we're going to have these values. And then you can check both arrays to see whether it is the player has marked it as solid. And then if all of these match, then that's good. Maybe. Or maybe there's a better way to do it. I don't know. Because like, what if we didn't have this? We have 4 different states. Solid. Transparent. Transparent is like a tentative staging solid. Transparent. I don't know. Wait, does the Game Boy have 32-bit values? If I had that, now I could. Okay, I'm just gonna do it like this. We're gonna have a uint 16t, which is going to be current. What do I call this? Board state, puzzle state, board state. It's going to have 15. I don't know how to write C. How do you define an array in C? Const uint something, but it's not a const. It's going to be sprites. It's going to be board state. Oh, I guess I did it right then. Okay, and then it's going to be a bunch of zeros. Raw? No, it's gonna be an array like this. Clang format, source, nonograms. Alright, so it's gonna look like this. And then we're gonna check whether you've pressed the A button. So we see like input and JA. Is that what it is? I don't actually have an LSP set up, so I don't have autocomplete. You can do this thing. Okay, I didn't know that. That's good. For future reference, for now reference. For literally now reference. What if it was 16? Okay, so this is the current state of the board. Let me look up the documentation. Boypad. They have like various header file documentation right here. Is it this one? No, they had like a better website. Is it this one? It's probably this one. Okay. Also, I should drink water. It is in fact time to hydrate. I'm going to skip the song. You all make sure you also are drinking water. Alright, welcome Piss. You should not drink acid. I think it's bad and you should not do it. Anyway, okay, what was I looking? I was looking for various things. I'm gonna search for J underscore. Okay, it is in fact J underscore A. This is if the A button has been pressed. So if input and JA, that means you want to mark the position that you're currently at. So we're gonna do board state of what do we have it as? Board state. We want to take your Y position, cursor grid Y, divided by 8, so that'll give you the position here. It'll give you which row you're on, and then you want to take the you want to take 1 and shift it over. So this is the value. Board state index. So we're going to set index here. Saw a tweet on the weekend that said they interact with streamers like a Tamagotchi. They constantly send stretches and water redeems to keep them healthy. I feel like I've seen that before. It is in fact a thing. It's going to be a row index. Row index equals board state row index, and then you want to take the column. So column, it will just be, you would need to invert it, right? You would need to take the current value and then invert it. If it's a 1, it's going to become a 0. If it's a 0, it's going to become a 1. So you gotta do, how do you do? What is the math? You want to do and then not? No. It's XOR. You want to do an XOR? But it should only apply to 1 bit. What is the meta here? Does anyone know? Bitwise operations invert bit. How to invert invert? Is that what it? Bitwise not. I want to bit flag. Bit flag invert. Tilde. How do I remove? I want if it's set, I want to unset it. If it's not set, I want to set it. Is it that? Wait, and then you can do 1, shift it over to cursor grid, X. Isn't that XOR? Let's think about this. We have, okay, so if the value is 0, and we have it as 1, let's do, we have an operation called underscore. This thing should be, wait, what am I doing? You want to always set it to, to 1, and then this is this. But then you have various other things. You want to make a bit mask that will set values. Someone just type it for me so I don't have to think. Bit flag, invert, value. How do I flip it? Yes, this is what I want. Okay. Is it just, it's just this and invert this? Is that really what it is? Inversion of the flag can be done applying the bitwise not operator. Is that the same? Is that what I want? If it's set, I want to unset it. And tilde. Okay, let me just try that. And then tilde, and then this. Unfortunately, on the Game Boy, we don't really have a way to like debug this. I guess there are debuggers, but I have not set that up. Negation is just tilde equals. Yeah, I mean, but wouldn't it like negate all the other bits though? Like I only want to invert 1 bit. If we had like this, and then I'm like on this thing, I want to turn this thing to a 1. So I need like some bit mask that when applied to this, like let's say I set this thing to this, and then this thing should be that. So we need some operation that takes this thing. Z. It looks correct. Welcome ISO Falcon. This looks correct. Okay. I'm going to trust you. I'm going to assume that is correct. So then we set the board state at that position. We don't have a way to visualize this. It's not the flags and ones with the flag you want to set 1 or 0 and then not the result. It's not, I think it's not the flags and ones, the flag you want. So I want, what do I want? So if I'm inverting this, this is a 0 and then this is a 1. So we take this, we've inverted it, and then we're anding this. So then this 1 and 1 is this. This thing is this. 1, 0 and 0. That's not 1. It should be. Shouldn't this be like I don't know actually. Everything 1 or 0 will stay 1 or 0, but the one you want inverted. I could just do this in 2 steps. I could simply just check the current value and then set it based on the current state. But isn't this cooler though? Bitwise operation. Bitwise, bit flag, cheat sheet. That's not what. Fantasy football, what are they talking about? You need to do it in 2 steps? No, no. Surely, C plus bit flags. What if I see how they do it? I want to unset. I want to invert a bit. Bits. No. Flags. Welcome, Owlman. Just XOR the bit. Okay, just someone just type it for me. Are you sure it has to be 2 steps? But what if you could do it in 1? Surely there's a way to do it in 1. Alright, fine. I just need to unset if the cursor is over this, I just want to set it to 1. But if it's already this, I want to set it to a 0. Just invert a specific bit. And I need the set of operations to do it. Whatever, I'm just gonna check the current value then. So let's see, we're gonna comment this out. So we're gonna do this, we're gonna do an and then this. This will give you the current value. If this is greater than 0, so this is XOR with 0, but it's not, this is determined dynamically though. You need to determine based on something. I don't know. Is this what I want? Is this even anything? I'm gonna do it in 2 steps. So we're gonna do this thing, the bit mask. No, no. No, I don't want to. So this is the current value. This is the bit mask. This is the desired output. We need to know what the bit mask is. So this is this, and this. We want this. We want to change the bit that is here. XOR should be this, but is that what I want though? Is that really what I want? You want to flip this one, right? You want to avoid flipping anything else. We only want to flip this bit. Everything else should be unmodified. It sounds like, but can you confirm? Are you sure? I'm just going to start doing it in 2 steps. And then if you can think of a better thing, then you tell me what it is. 0 XOR 0 is 0, so it's fine. You're telling me it's this. Hold on. What if we did what if we did this? Python 3. I don't have Python 3. It's what I want. Okay, well, let's just try it. Okay, we have Python 3. So we have our bitmask, right? We have our value. Does Python support this? Okay, it does. Okay, so this is our current. Is this. So current, we want to change this bit, right? So we do current, and the current thing we have is this thing, and we have 1 shifted over by 3, right? 1, 2, 3, that's 3. Why doesn't it print it? Print. Invalid say, okay, they don't have, right. Just do this. Because, okay, we're not modifying current in this example. We just do this. I want to print this as binary. Oh man, what the frick? Wait, but that's not right. That's a 1. Current XOR this. Wait, is that right? Oh no, that is right. That is right. So we've unset it. So then if we set it to, if we set current to 1, we should get 9. Okay, wait, that does work. That does work, guys. You've done it again. Genius. So okay, that works. So we have this thing. We'll toggle the bit at the position. We take the current row, we shift this thing over. But actually it should be, cursor grid X should actually be subtracted. Because if we're at 0, we're shifting to 0, so it should be the thing on the right side. So we gotta take puzzle size and then subtract cursor grid. Right, because if you were a 0, if the cursor is here, we would like to toggle this one. But then we gotta do other stuff. This is toggling all other bits because I have that at the front. Oh, right, yes, you're right. Yes, that was from a previous thing that we had set. But this should theoretically be it. And now we need a way to visualize this. I don't currently know how to do that yet. We're gonna have to... It's gonna be kind of annoying. We're gonna have to go through the VRAM memory, find out which tile corresponds to our current cursor position. So we're gonna have to like find this position. And then we're gonna have to like and the bits specifically. We're gonna have to modify these specific bits. And also make sure that these are untouched. That's gonna be annoying. Okay, let's try to let's try to figure that out. Okay, so we're gonna look up how to find the value GBDK documentation. Doesn't sound too horrendous, yeah, but then like it might modify multiple tiles. Like let's say you're actually like here, right? It's gonna be this tile. You would have to modify potentially 4 different tiles. Like let's say you were like this one. No, like this one. You're modifying this tile, and also the one next to it, and also the one below it, and also the one below and to the right. And then you're like, in this one, you have to make sure you're modifying this one. I don't know. There's some way to do it. Okay, what are the documentation? How do I find tile at position? Get tile. Get tiles. No, I want to get the tile at a current position. Oh no, but that's... Wait a second. Hold on. I can just hard code it because the values are not going to change. The window is not scrolling around. Everyone loves having magic numbers. Okay, so we have this... We have this thing to turn a screen X into tile. I need a function that will turn the tile to a set of tile number. Oh man. Okay, wait a second. So we have to take a thing from 0, 0, tile coordinates, convert it to pixel coordinates, convert that to tile. Wait. It might be more convenient to call this grid coordinates. Puzzle grid coordinates. To pixel coordinates, and then this thing will give you a tile index array, possibly of 4 things. So if you're at 0, 0, it should return you the top left of this point right here. So if you're at 0, 0, it should be at 64, 64 comma 56, which I believe would be this position here. And then you gotta find out which tiles are at that current position. I'm pretty sure there is some function. Fat arrow, you can't call them that. they were just born like that. They can't, you know, they can't control it. It's just their body structure. Get tiles. Get tiles. Copies rectangular region. That's not what I want. Get data. Get background. Wait a second. Fill background rect. Fills a rectangular region of tile map with the background. Wait, what? Tile map entry. No, that's not what I want. I want tile set. This is confusing because there's tile sets and tile maps. The tile set is this. This is the tile set. And then the tile map is this. This is the tile map. So we can find that this position is this one. Like, this is going to be the annoying case. You have to modify 4 tiles. Modify up here, up there. I don't know. This is stuff that I feel like would make sense to do off stream. However, I'm doing it on stream. So we're going to have to think. We're going to have to think. GBDK get tile index at coordinate. Tile functions. Set win tiles. Get BKG tiles. Welcome, what's abuts. Get BKG. Watching intently while I eat my bagel. What's in the bagel? Is it cream cheese? Is it butter? Is it scallion cream cheese? Dox your bagel now. Get background tile XY. Scooped? No, scooping. Salmon. Bro, I've actually never had a bagel with salmon. That's a common thing to put on a bagel. They call it lox. It's like cured salmon. But I've never had it. It's usually pretty expensive. Bagel, but pronounce it bagel. Bagel. Any Canadians in chat? Do you call it bagel? Bagel. What are they doing? Get background tile XY. Get single tile T. Background layer at XY. In general, avoid reading VRAM since that memory. Okay, I think this is what I need. If I can convert my current... I'm going to rename this from tile to puzzle grid coordinate. Because tile is overused. We're using this in too many places. Tile to screen. So instead of tile to screen, it's going to be grid to screen. Grid coordinate. Grid puzzle grid. Grid I don't know. Grid coordinate to screen. Grid cord to screen. Grid cord. That's a new Discord for grid members. Okay, so we have this function. This function here. Get background tile XY. So we have We toggle the bit, and then we know the current. Okay, so we need to convert your current cursor grid to a position on screen. Screen. Oh no, you already have that. We just use this. Grid coordinate to screen X. Do this. Grid X. No, this is a screen X. Screen Y. Okay, and then we get the tile that's at the current position. But then we need to know like the offset from like within that tile, bro. Okay, so we get tile XY. X, screen X, screen Y. So this is the tile coordinate. The tile index. And the tile index specifically is going to be this, where you are currently in this thing. Then, let's see. So once you've gotten the tile, let's not consider the fact that it can cross 4 different tiles. Let's just output something to the screen, just so we know it like kind of works. So let's see, we have the tile index, and then you want to be able to like get the value, you want to like modify the tile value in VRAM. I think there's some way to copy a tile to a buffer. Get win data, is it get BKG data? So it'll copy from a tile to some pointer. Pointer to destination buffer for tile pattern data. Let's see. So we're gonna do get background data. We're gonna give it the tile index. This is the first tile. And then we're going to get a number of tiles is going to be 1. We're going to need a place to put it. So since we're getting one thing of data, we need something that can store 16 bytes. So we're going to do uint 8t buffer 18 equals 16. Is that how you do it? Yes, equals this. Now we should set this outside. It probably doesn't matter. I'll put it here. Tile buff. This is going to be a buffer for storing intermediate tile data. So we pass it the value tile buff. Now, do I need to do this? It's declared as an array, so I can just do this, right? Because it implicitly is already a pointer, probably. Okay, so now tile buff should have the bytes that correspond to the tile. Welcome, Tag Barrel. And then we need to modify that tile. Then what? And we set tile. Hold on. How do we set background data? Set background data. Set VRAM tile pattern data for background/window. Writes number of tiles to VRAM starting at first tile. Okay, what if for now we simply just invert it? For uint at index equals 0. I is less than size of tile buff. I plus plus. You want to do tile buff of I. Let's just invert everything. Wait, how do you do that? How do you simply invert the colors of everything? Is it XOR? What am I doing? What are we doing here? Does this do what I want? I want to unset. Yeah, that's what I want, right? I want to unset everything just for now. I'm just inverting everything for now, just to check that something works. And then you want to set background data. Tile index. Number of tiles 1. Tile buff. Clear invert. I just want to invert for now. We're just debugging. Does this compile? It does, and nothing is happening. Okay. Actually, I think GBDK does have a print function that will print to the top of the screen. Yes, I want that to turn into that, just for now. Standard io.h. What if we simply did print tile index? Does that work? Does not work. Too many print function print implicit. Oh, printf. Wait, how does printf work? Is that? No, nothing's happening. Printf. Printf. Hello world. Should that not have printed something? Am I not doing this input stuff correctly? What if we just for now, at the very beginning, we print hello. Tile index, you've missed everything. Tile index. Okay, so printing does work. Doesn't look like a string. Tile index is an integer that represents the index in the tile set. Welcome, Pimp. Okay, so print does work. What if I just in here, I just print something? I want that. No, the game, it doesn't have, oh no, you're right. I don't know if this thing, oh, hold on. It is called printf. Printf, it's gotta be string. No, you're right. %b tile index. Was this the pointer? I don't even know. So nothing is being printed. I just want to check that something is printed. If I press the button, something should be printed to the screen. But it's not. It actually does not work. So I'm thinking my input just does not work. If input and JA, but shouldn't that work though? What if, well, okay, let's set the cursor grid to be 5. If I press A, we should be set to position 5, but it's not working. So that means this thing in itself just does not work. Contrary to popular belief, the F stands for freak. No, you can't possibly be that way. Reject all. I don't want your cookies. We're gonna do joypad He's right. Print freak. Macros. Here's a generic example. Joypad and jwrite. J_a. But that's what I was doing though. Was I not literally doing this? If input and JA, cursor grid equals 5, but it's not working though. Joypad current, joypad input, joypad current, U8 int t. uint 8t, unit 8t, input, joypad. If this thing, that should do something. I'm pretty sure that should do something. But it's not. Why is it not doing? Oh, because I'm doing it after this. Because this is set afterward. Cursor grid. Wait, no, because I do this here. What? Cursor grid X. So why is this not being called? Cursor grid Y. Give input and jwrite. Okay, what if I just made it so if you pressed right? If you press right, your position up. Okay, so that does something. So pressing right works. For some reason, pressing A does not work. Why is that? It does not work. Joypad. Display on, show sprite. Simple sprite. Is the Z button not A? I thought it would have been, hold on. What's the A button? Controls, options, configure input. S. Why is it S and A? What the frick? No, this should be Z, this should be X. Okay, that's what I was doing. Wait, but it doesn't work. It also doesn't work. Look at that FPS. Wait, what is turbo mode? What the frick is turbo? Speed. No turbo. No turbo. Turbo? Okay, so Z does not work. S. Oh. Okay, wait. It did not configure my input. It didn't save. Oh, I didn't press OK. Okay, A is going to be Z. B is going to be X. And then OK. Okay, so this works. Let's not print hello. For now, let's try to not print this just to see what it looks like. So, okay, so it is flipping some bits. It's flipping specifically this for some reason, which is not what I want. Why is that? Why is that? Also, we need to store previous input because I think it's, if you hold down the Z button, it's going to apply to multiple frames and then it's like flipping and unflipping. So we're going to have input previous. And then at the end, we're going to set input previous equals input. So then if you're pressing it this thing and you were not previously pressing it, and not JA. Is that how this works? If you were not if it's like this, okay, it's like this. If you're pressing it now and were previously not, are there macros for this? I'm pretty sure there's some macros for this. Maybe not. Okay, maybe that was a GB Studio thing. But okay, this one should theoretically make it so that it only toggles when you press it on one frame. Okay, so every time I press it, it toggles that specific thing up there. But why specifically that one? Oh, because I'm setting the grid position to 5. Just that was there for testing. Okay, if I don't do that... Never mind. Wait, it did something? It's like, okay. If we go to different places, it toggles... It does toggle various things. But these appear to be the same thing. Wait, do you see that? What was that? You're toggling various bits in memory. Can we take a look here? Okay, let's go up to the top. I should really like throttle this. Okay, so we have this. So that toggles 1. Welcome, Tiny. Good Game Boy Gamonday to you. Welcome, Stove God. And then if we move over here, that toggles the same thing, which makes sense, right? Because we are currently here. No, that doesn't make sense. We toggle this one. This is all toggling the same thing. That's our x coordinate. Am I not considering the y coordinate? Is that what it is? So we have tile index. Okay, so tile index get position screen x screen y. We are converting the current screen. Okay, what if I just print out the screen x? And screen y. Just to see. So every time we press Z, it should print out where we are on the screen. Nope, it actually, I don't know what just happened there. Oh, okay, what is this? It is in fact not printing out. Oh, wait. I need another space. There's gotta be a space after it. That did something. Oh, it's because, okay, it's because at the top we set, we're using a different tile set for the top. Once it reaches here though, it'll be the right numbers. Okay, so we're at 650, which doesn't look correct to me. No, it's probably 106.50. Okay, so we're at 106.50. If you move over here, it should, I expect this to be 112.50. Okay, so that's right. I expect this to be 112.62. Okay, so that does work. Whether that's our actual coordinate, I don't know. Wait, we could check. F3. Okay, so this one, we are currently located here, which is something. So we're doing, oh, it's because, wait, I think it's because we need to set, we need to unset this thing. We need to, hold on. We gotta set the LCDC register before we set this, because we're changing specifically the bottom tile. So we gotta, before we set background data, we need to set this and then unset it, I think. Let me remove my print statements. Okay, maybe not. Maybe I was wrong. Oh, what was that? Did you see that? Yep, that sure is It sure is something. Something sure is happening. It sure is doing something. I think I should also make it, just to make it easier to debug. For now, you have to tap every single time you want to move, rather than holding it down, because when we hold it down, we go too fast. We're just going way too fast. So input equals joypad. I need like a function that was like just pressed. Define just. And then you take the flag. And then this is specifically going to be input and flag and input previous and flag. Not this. Is there a better way to do this? Input previous, whatever, it's fine. Input and flag and not this. So then we're gonna have just pressed JA. And then this one's going to be input, and this is going to be if just pressed J left. And then also this. I feel like these are usually lowercase, right? Macros are usually, if they're functions, are usually lowercase. I should call it input pressed. Input pressed. Input just pressed. Nah, whatever, just pressed is fine. Freshly squeezed juice, just pressed. Okay, does this work? This is the question. Okay, so every time we tap, it goes. So it doesn't go like crazy anymore. And then we set this one. It's not working the way I think it does. It is setting various things. It appears that it's setting things that are 8 apart. Doesn't it look like this? Is this 8 tiles away from this one? So this one is 1, 2, 3, 4. Oh, it's 6. 6 is actually our tile size. So that's something, right? That is in fact some sort of thing. You know, what is it exactly? I don't know. I just don't know. So we get the tile index. Get background tile XY. We have our current screen position. Get the tile index. What if I print it out? The tile index. And then I also disable this thing up here. This thing, we don't really need to do this for now. It's gonna show messed up at the top, but that's fine. That's expected. Okay, so tile index. Wait, it doesn't work. Do we still have to wait for it to go to the bottom? Okay, so we're at tile index 0. Which is correct. Is that correct? That's not correct. Why is that 0? 0? What are we doing? What am I doing, guys? Handle scanline. Just return. I would simply just return. And then we're setting this thing to be this. We don't need this for now. Okay. Tile index is always 0. What? Why? Oh, because this got overridden with the font. Oh man. It complicates things, because to print stuff we need this section in VRAM to be the font that we're using. And then override some stuff. Is there some other way to do this? So we are toggling this one. But like, why is it setting everything to this though? That's my question. Why is it setting every tile map to this thing? What if I remove the print? If I did not have the print, I did this. So it's updating tile 0. If I move over 1, you should still modify tile 0. Okay. This one I would expect to modify tile 1. But it's also modifying tile 0. So everything on this row modifies this. This one also modifies the same thing. Wait, am I not dividing by 8 somewhere? I thought this would be screen X, but I might need to do a division by 8. Because it might actually take the tile position rather than... Oh wait, okay, no, I figured it. That's what it is. It takes tile position, not like the screen coordinate. Okay, so we have some sort of some logic that it'll toggle the value at the top left of the cursor. So like whatever pixel this thing is on is going to change the tile. It's going to flip it. Right, so we have now successfully marked picross. This is a little bit messed up, but it does do what I expect. So now what we need to do, we need to figure out if the grid is in multiple tiles. So we need to take the current position and then current position plus 6. Is that 6 pixels? We have 1, 2, 3, 4, 5, 6. It's actually 7. 1, 2, 3, 4, 5, 6, 7. But okay, we can consider this thing as being part of the previous thing. So it is 6. So we need to check this one. This one. I guess we don't need to check this one. Right, this is plus 1, 2, 3, 4, 5. Plus 5? Wait, 1. So we have this coordinate. I should probably commit this first though. We have something that can toggle stuff in memory. Let me remove this stuff first. I actually think we don't need this. Yes, of course, multi-grid plus 6 exactly. You know exactly what's happening here. Glad that you understand that I've been explaining things so clearly that anyone can understand. Okay, turns out I do still need that thing that I removed. No, the stream is not ending. It's just the song on the playlist. Okay. It does not compile. Unidentified register, because I accidentally pressed Control A, which increments a value in Vim. Okay, now I don't know why it does this though. Every time I toggle it, it does like flicker. Oh, it's because I'm setting... Wait a second. I should be waiting until the V-blank is done. Because I'm doing it mid-render, I think. I think this thing is running mid-render. And so the value, it is setting this thing. And then it unsets it when it's midway through. Whatever, this is fine to commit for now. Because we have something that kind of works. Alright, what have I changed? Grid coordinate to screen. The blanking. The V blank. We have board state, we have input previous, we have this stuff. Okay. Add partially working toggle. What do I call it? Toggle of tile data. Okay. I had to go to a long meeting. What did I miss? Did he compile? Yes, I have it so that you can toggle. What the frick is that? What is that? Why is that there? Wait, is it not toggling? Wait a second. I noticed that this thing is not actually... Wait, these are using that stuff up there rather than the current thing that's down here. Why is that? So we set this to the bottom. This thing is using the bottom tile set. It's because we're drawing it here. Set background data. I feel like maybe set background data waits for something. I don't know. This, I feel like this maybe blocks. I don't know. Whatever, it's fine. It's probably fine. So we have something that can toggle. So now we just need to... Oh wait, but it doesn't untoggle it though. Are you seeing this? It doesn't actually... Didn't I get this to work before? Does it only work if I don't do the scan line handling here? If I remove this stuff, we should be able to toggle and untoggle. Yeah, this one does work. But if we remove the the other thing, it doesn't work. Only has the line on the top boxes. Yeah, it's because it's based on tile. So whatever tile's at this position, which is this one. This one is here, which has this tile. Why does that happen? If I change the register midway... Oh, this is kind of complicated. This is kind of complicated. What if I didn't do get background tile XY? What if I simply, like, I know where things are. If I simply just calculated my offset from from this, I know for sure that this one is tile set 0, tile number 0, and then going across, it's incremented. So if I were to simply do custom logic instead of getting it from here, I have my own function. So we know, let's see. Screen X, this is divided by 8, by the way. If I take this one, we'll get alright, how do we do this? So this will give you the tile. Tile X. and then tile Y, and then you want to, what do you want to do? What do we want to do here? I would like to check okay, I would like to check whether we're here. If we're at this position, row 6, column 7. Oh, dude, wait a second. Wait a second. Row 6, column 7. We're gonna calculate the tile index based on my knowledge of where things are on the screen, which is fine because it's going to be the same across every screen. It's picross, it doesn't change. So we have this one. So we have tile X minus so this starts at column 7, so we want a minus 7. Wait, do I want a minus 7? No. I want to subtract 1, because this thing... No, I do want a minus 7, right? 1, 2, 3, 4, 5, 6, 7. So that'll give you... No. What am I doing? Guys, what am I doing? Tile X minus 1. So we have the coordinate relative to this. And then we need to do screen tile Y. So this is, what am I doing? I'm losing my mind. Tile Y minus. So this is the start point. We want a minus 6. So this will give you this. And then you want to multiply this by the width of this. So this thing is actually, let's enable the grid. This thing is actually 17. This thing is actually 18 tiles across. So tile Y times 18 plus this. So this is our tile index. And to prove that this is true, I'm going to run it, and it's going to work. It's going to work first try. It did not work first try. Tile Y minus 6. Tile Y minus 6 times 18 plus tile X. Welcome, Nanodan. I love the gameboy and picross. True, true. This is the picross you know and love. It looks exactly like this. Oh, wait, it works unless we're up here. So you can toggle this, you can toggle this. For whatever reason, when you're up here, it's broken. But that's somewhat good, because I know part of it is correct, at least. So if I only toggle this... Okay, like, I don't know why that's happening. There's something there that is broken. Oh, maybe because I'm doing this. Maybe because I don't need this anymore. Oh no, I should have done this up here. This should have been before get background data. That's probably what was causing the issue. Nope. That was in fact not it. It's actually not it at all. Welcome, Yurga. Yep, this is picross. This is the picross you all know and love. Looks like 15 versus 16. What is 15 versus 16? I don't know what you mean. What does he mean by this? What's drawn is less than where selected. What's drawn is less than where selected. What do you mean by this? What does that mean? Why is that happening? Get background data. Tile index. So we're setting this thing to draw the bottom part of the grid. And then we unset. What if I don't set this? No, because then it's different. I probably need this logic to be here. I probably need to like store what value I need changed and then actually execute it here. Or what if I had this at the front? What if wait v blank done is done at the beginning? I guess that's functionally the same. Never mind. This is actually pretty complicated. How do they do this? What if instead of doing get background data, because I know we always want to get the value that's down here. Because I think get background data changes depending on the LCDC register. And if I know that I always want it from down here, there's probably some way to do it. Get data. Copies arbitrary data from an address in VRAM to a buffer. Yes, I think that's what I want. Copy data from an address in VRAM. Pointer to source VRAM address. Pointer to destination buffer. We're copying raw bytes. Okay, so we want what is this one? VBK Bank 1. It's in Game Boy Color mode only. Which value is equal to 0x800? They don't have a constant for that. Game Boy. This is the top portion of VRAM. What about this one? We want to modify from here. Tile index 256. Oh, now I see why they did it the way they did in Mario's Picross. They actually put this out in memory like this. Whereas I had it start from here and then like after this it goes up here. They probably did it this way because it's easier to calculate direct offsets rather than like from an offset from here. I don't know. I kind of get it now. I was like, why did they do this? It's harder to access memory this way. But they were probably just using raw pointers. They probably were not like using this BKG offset stuff. I don't know, man. Also, I'm like 9 minutes late to drinking water. I'm gonna do that right now. Alright. I have done it. Okay, so I want to calculate, we're going to take from this position. VRAM 0x900. We're using raw addresses here. What if I just went on the GBDK GitHub and then just searched? No, but this is like, wait. They don't let you search on GitHub unless you're signed in. It's actually messed up. I guess we're just hard coding. Okay, so get data. Wait, in general, avoid reading VRAM since memory is not accessible at all times. See coding guidelines. Avoid reading from VRAM. If GBDK a API function which reads from VRAM, it's called during a video mode when VRAM is not accessible. That function call will delay until VRAM becomes accessible. This will cause unnecessary slowdowns. It's also not supported on NES, whatever. It's better to store things such as map data in general purpose RAM, which does not have video mode access limitations. So you're telling me that I should make a copy of VRAM? I don't think so. It'll cause slowdowns, but that's fine, because like it's picross. You don't really, doesn't really matter, right? But is that why? Is that why this thing flickers? That's probably what it is. Okay, so instead of get background data, we just do get data. And then we give it the pointer address. We're gonna hard code this thing in here. We're gonna add tile index. And actually it should be signed because it's gonna be relative to that other thing. So we have a signed tile index. Tile index might be negative, that's fine. Get data, and then we want to get 16 bytes. Wait, we want get data from data destination. So we want to put tile buff. Picross should have slowdowns and hit stop each time you press a button. Exactly. That's how gaming works. So I think we don't need to set this. We don't need to set this. Let's run this. It's gonna work first time. Oh shoot, guys. That's all you need to do. Just memorize various addresses in memory and hard code those values into your game. Yep. It did work. Now the thing is though, it doesn't flip. The ice cream truck is outside. Now what's going on with this one though? What happened here? What is this? I think it's using the values from up there. Let me uncomment this stuff out. First time I'm hearing this truck, it's been every day, bro. It's literally every day, bro. Picross should gradually remove your skin each time you pie and or cross. That's impossible. They would never do that. To me specifically. Oh, and I think it's doing this because I am setting the value. Because I'm doing set background data. I should just be calling set data. Because now that I'm dealing with raw pointers, I can just set the data however I want. Okay, so now instead of doing this, we'll do set data. We want to set the VRAM address and data. Okay, so we set tile buff is the second argument. We have 16 bytes. And we have 0, we have this one. Uint 16 T. It's going to be VRAM address. and then VRAM address. Wait, shouldn't it be tile index times 16? VRAM address. I'm reading from Wait, how did this work? This should not have worked. Wait a second. Get data, VRAM address, data. Oh no, that's fine. Is that fine? That's not fine. Why did this work? This should be times 16. But it did work. Get data. VRAM address. I don't know why it worked, but I guess we'll see. Okay, what do we have here? Line 144. Alright, we're missing a semicolon. Of course, classic. Oh, look at that. It works. Brilliant. It's actually working. That's great. Okay. That's good. Oh, actually, this is not a uint 16t. It's a uint 8 pointer to VRAM address. Which I guess also works the same way. It's an important semantic difference. Actually, despite it being correct, you should not assume this behavior. Okay. So that's good. We don't need any of this stuff. I'm going to need to thoroughly comment this because I don't know. If I was to look at this later, I'd be like, what the frick is he doing here? What is he doing, man? Tile X, screen X. Okay, we don't need screen X. Tile X. Tile Y. You know what assuming does? You're assuming that I know, but I don't know. And instead of tile index, it's really tile offset. And instead of tile offset, no, that's fine. It's actually fine. Okay, so we have this thing times 16. You'll get data. We should probably put this in a constant somewhere. Invert tile. Okay, let's commit this. Correctly invert tile. Okay, so that's good. I probably should have formatted it. What did they change? They moved the pointer to be part the star to be part of this thing. That's fine. You know what? That's fine. Okay, now what? Now we want to specifically, instead of working on a per tile level, we should be working on a per grid level. So like this thing right here should modify this out here. So we need to add okay, we need to consider the top left plus 6. So for here, you'll modify this tile, but we need to get the offset. We need to get the multiple of 6 offset from this position right here. But for what? For what though? That's a good question. It's a good question. I don't know. Isn't this so fun? If I was doing this in Godot, it would be like, you just make a grid. You just draw grids. Now we're like, we gotta modify the VRAM. You gotta update VRAM addresses. Got a hard code 0x9000. Gotta do some bitwise operations. Okay, so we have the top left. We need to, what do we need to do? What do we even need to do here? What if... What do we do? Well, what am I doing? I think we did need the screen coordinates. I did an optimization earlier for no reason. I simply remove this despite not needing it. There's going to be screen X. Screen Y. Okay, so we have screen X. We want to see, what do we want to see here? What are we even wanting to see? The screen X should be we should take grid, we should define grid top left, grid origin, what am I calling this? Grid origin screen X equals 58. And then grid origin screen Y should be 50. And I should do define grid, what do I call this? Grid pixel size, grid size pixels, grid cell size pixels equals 6. Grid cell size pixels. Okay, do I hard code 6 anywhere? Probably. Well, this 6 is not the same. This is a different 6. This one is, what is that one? I don't know. So this one, if I did this instead, grid origin screen X, yeah, that's the other 6. Grid origin screen Y, screen offset screen, I don't know, let's just call it this for now. And then tile X, tile Y, we have this one. This one then should not have this. If I simply did not have this, I believe this should still work. Maybe. Probably not. It's probably not going to work. It doesn't even compile. Why? Error token equals. On line 126, column 45. What? Oh, there shouldn't be a semicolon. Right, it's a macro. There should not be a semicolon. But it's also wrong. Grid origin screen X, grid origin screen Y. Oh, this should not be there. Bro is using semicolons. I can't believe that this is true. He has more semicolons. 126 is still wrong though. Why is it still wrong? Column 45. Is that even? That's column 45 right there. That's not even an equal. What is that? Is this really column 45? This is column 45. Did I not save? That's what's going on here. Syntax error. Token equals. What did I do? What the heck did I do? What if I undid? wait a second, hold on. Grid or oh, because of this, I copied the wrong thing, bro. Me when I have a typo. It's still wrong though. Grid origin screen Y. Grid origin screen X. It shouldn't be equal. This is not, guys, this is not even, that's where the equal is. That's not how defines work. Okay, so that should work. Okay, so it's updating the wrong thing. Which tells me that they've done everything wrong. So tile X, this is actually not even right. Screen X, tile X. This thing should be plus, what is it? 1, 2, 3, 4, 5, 6, 7. That's, what is it? 1, 2, 3, 4, 5, 6. 6. That's what the 6 was. Tile X plus 6. Okay, magic number 6. That's good. Right, tile Y times 18. To do, document these numbers. No, I should do it now. So 18 is what is 18? 18 is width of. Wait, I have values for this. 18 should be actually what is it? Build bat 18 is actually this. It should be nonogram bottom width whatever divided by 8. Is that true? 144 divided by 8, is that 18? Whoops. Oh, that's an unfortunate thing to search up. Yep, it is in fact 18. That is 18. Okay, so we can do this thing divided by 18. Nonogram bottom width divided by 18. Grid screen. Puzzle size 15. Tile count. Is that what I want? Nonogram top 15. Nah, it's fine. 18 is width of nonogram bottom 6 is offset from where grid starts. Six is offset, is tile offset from left. All right. Right. Does this still compile? It does. What does this say? Dog. Warning, auto variable may be used before initialization. Input previous. Input previous should be equal to 0. And then line 88, something got compiled, something got optimized. Converting integral to pointer without a cast. Unsigned int fixed 138, 136. VRAM address, this thing. But how do I do it though? uint 8t. Is that how this works? Isn't this a funny compiler message? This is specific to SDCC. They keep referring to a dog that optimizes your code. Evelyn, the modified dog. Conditional flow changed by optimizer. So said Evelyn, the modified dog. So on line 88, a dog has optimized my code somehow. I don't know what specifically here it has optimized, but it has done something. That's the dog right there. That's Choco J dog. That's a different dog. Conditional flow changed by optimizer. The dog, what the dog doing, guys? What can they possibly optimize here? Else if y greater than equal to 6 and y less than equal to 17, conditional flow. I wish it would tell me, because I just don't know. Whatever, it's fine. That's fine. So instead of being screen X, I should format that. You gotta format your code, guys. Instead of being screen X, it should be something. It should be something, though. But what? But what's even? I feel like this is more confusing than what I had earlier. Screen X, you know what? Let's undo everything I did. Simply because... No, it's fine. It's fine. I'm sure it's fine. Screen X. It's not. It's actually not fine. I think it's not fine. We should see what we changed. So we had this tile y minus 6, and then tile x minus 1. Is that true? Does this still work? It does still work. Anyone else changing the conditional flow? Wouldn't that be a cool rap name? Conditional flow? Dog? The dog that changes the conditional flow? I think that'd be cool. Evelyn the dog? What the heck is this? Why did they do this? Are you seeing this, guys? Why would Clang Formatter add this many spaces, bro? Why not just put it here? What were they thinking? What were they thinking? Man. It doesn't make any sense. What if I did this? Do you think they would undo my changes? That's evil. That's actually so evil. Whatever, it's fine. You have a Clang format setting? I know which one it is. Which one? I don't have any. I don't even use Clang in my day-to-day. Tile X, Tile Y, Screen X. I'm not even using Screen X or anything. Why am I doing this? Screen X, I surely did this for a reason. Because I wanted to subtract this to get the offset. Oh my god, dude. That's what it was. Whatever. You know, I'm going to commit this. Fix warning about pointer cast. Anyone casting their pointers right now? Who up casting the pointer? Post this when you post the pointing emote. The dog that changes. Conditional flow says stays starting v blank. V blank. Isn't that the Fortnite currency? I was gonna say Uma Musume. Isn't that the Uma Musume currency? No, that's carrots. Okay, so this one, it's going to be so I do need this. I do need offset. What is this? Grid offset X equals screen X minus grid origin screen X. Wait, this is also wrong. The dog that changes, the conditional flow stays. Oh, I see. It was a haiku. I didn't even understand. But now I understand. I totally get it now. It actually makes sense. It makes so much sense. What is it doing? You want a grid coordinate to screen X, grid coordinate to screen Y, grid origin screen X. I found it. The setting is align escape new lines can be either don't align, left with last line, or right. You know, I think I'm fine. I'm just gonna use the default settings. That's the thing about having an auto formatter, is that I'll just use whatever default, even if I don't like it. Because it bothers me. When people don't like the Rust format default and they change it and it's like not what I'm used to. I'm like, bro, just use the default. Literally, just use the default. I'll format this. Rust format, see, no, it's fine. Rust format default is fine. If you don't like it, that's fine. Just use it. You'll get used to it. There's things that I don't like about it, but I accept it. Because standardization is more important than your personal opinions on code formatting most of the time. I like the Rust format default. I hate the Clang format default. I agree. I actually like the Rust defaults. I think it's good. Alright, so we have grid offset X. We have grid offset Y. And then what? Then we want to get the... We need to divide by 6. Is that true? Is this true? We would like to divide grid offset X by 6. Would you box a string though? If it's dynamically allocated, you would have to, right? I guess you don't have to. I don't know. I don't know what I'm saying. I don't know, man. It allocates, yes. But you didn't capitalize string. I know that capital S string is allocated. However, lowercase s is just the general term in programming. Small one be str. Well, I know, but that's in Rust. When you say just string, it implies, you know, like str and capital string are both strings. You know what I mean? Okay, we have grid offset. What was I trying to do? Only Rust boxes. Rust is out there boxing. So we want to get the offset from the top left. This is going to be so complicated. So we have the tile. We need to... What do we need to do here? So if we round... Okay, hold on. Here's what we do. Tile X. Tile Y. Tile... Screen... Wait. Tile X. So we have this. Tile X. But we need tile screen X. That doesn't make sense. Tile screen X. Yeah, I was also thinking of boxing, but I didn't say it. But thank you. You always understand. I can always count on you to understand. Tile X. This. Tile top left screen X. Okay. And then what? And then we gotta take the modulo, right? Or are we taking the modulo? No, what am I doing? We have to No, I need to take screen X modulo 8. Right? Screen X mod 8. So this will give you the offset from the nearest top left of the tile. If I program for multiple days in a row, I'd actually be reasonably fast at this program. You don't need to be fast, you just need to be correct. So we have this position, and we have this. If we modulo by 8, we'll have 2. Right, because then it'll be this position. And then that'll give us where to shift it by. Right? Screen X modulo 8. Horizontal shift. Shift right. And then screen Y, this is going to be shift down. You're like, what the frick is shift down? Is that true? Shift down? Shift right. So we have this position. And then instead of doing this, we will do we will do this thing shifted by Shift R. Let's just try this for now. I think this will then show the correct thing on the left side. Okay, so now, wait, that doesn't work. No, it doesn't. It does. No, it doesn't. It does kind of work. So this tile right here is actually here, but it's only drawing this part. It is correctly modifying only the thing within this, but we need to do the same thing for Y. So we need to do I equals shift down, actually. So now we have, that doesn't work. What is this? What have I done? It doesn't make any sense. Shift D. I is less than size of tile buff. I plus plus. I should be, wait. It should be Shift D times 2 because we have 2 bits per pixel. Right? So, okay, so we have, okay, so this is correctly marking from the top. It's marking a bit too much, so we need to cut it off at the bottom, but it's also not going to the next tile. But this is promising. We have figured out some things. Various things have been figured out. I think we also need to add a 1. Right? Shift R, screen X plus 1. Mod 8. Because we don't want it to also mark the this outline. So it is marking in the correct region. It may be marking a bit farther, but that's acceptable for now. And then what? And then what? Guys, then what? Surprisingly, correctness is really frustrating without accumulated experience. That's fine, you know, that's fine. Eventually, it'll be there. Isn't this cool? No, this is the stream ending song. It's not done yet. But it will be soon. Okay, so we want to avoid writing past the current cell. This is quite complicated. It is quite complex, actually. So we should take... See, the issue here is that one tile may be in one... Sorry, one of these grid cells can be in 1, 2, or 4 corresponding actual tiles. And so our code needs to consider that. It's kind of complicated. Imagine playing picross like this. You're like, oh, okay, you're just gonna you're gonna mark this as based on which tile is in the tile set, rather than like, you know, like what makes sense. It's crazy. That's crazy. What are they doing? Game jam game, memory management. Alright, so what's the logic for this? It's gotta be what? Has to be what? It's gotta be something. So we start from this, go down, we do this. It should not be stopping at size of tile buff. It should be... So we maybe need one thing that's to the right. If we can do like... Oh man. How do we do this? How do I do this, guys? So then, okay, has right. uint 8t. Has right is going to be if tile x, if screen x plus grid cell size pixels divided by shift 3 is not equal to tile x. Right, so then has right, has down, screen y plus this thing is not equal to tile y. It should be if it's greater than, specifically. All right, so then this is the current tile. If it has right, then if it doesn't have right, then you should do something. What specifically? I don't know. I just don't know, guys. Tile index. Screen x plus this thing, but it's gotta also be -1 though. It has to actually be -1 because you don't want it to be here because that's already the next thing. It's actually, so you're from here. +6 would be here, so it'd be +5 actually, right? 1, 2, 3, 4, 5. Is that right? Is that even correct? Sort of here. You're like, this is the current one. So you need 1, 2, 3, 4, 5. Yeah, that's 5. 1, 2, 3, 4, 5. That's good, right? That's good. Has right, has down. And then what? And then what, guys? What even then? Tile to right. If has right, then I'm just going to copy this for now. We can optimize it later. Tile index is actually tile index is this thing plus 1 because you're to the right. VRAM address is this thing. It's fine. You want to get the data. And then what though? And then I guess this Shift R, Shift D stuff should be it should be the remainder, right? This one, Shift R, Shift D should be. So if you're to the right, you want to shift it to the left, actually. Screen X plus 1. So let's see, it's from here. It's plus 1, it's there. But you don't want to do that. You want to do what do you want to do? What are we doing? Shift right. It should be negative something. It should just be whatever this isn't, right? It should be Shift R. It should be 8 minus... Wait, is that right? 8 minus this. 8 minus the previous. It should be 6 minus the previous. It's gonna be grid cell size pixel minus Shift R. Should actually be Shift L and Shift up. Grid cell size pixel minus Shift up. And then it's got to be this thing, Shift left. This thing should start from 0 and then stop at size of tile buff minus Shift U times 2. I think. First try. It's gonna work first try. Oh my god. It did not work first try. It actually is really messed up now. Oh no, that makes sense. It should not be plus 1 because it could wrap around. It should actually be tile Y, tile X. Minus 1. It should, yeah, it should just be this. What the heck? What is that? What is that? Tile index times 16. Tile buff. VRAM address. Size of this thing. I is less than Shift U. Shift up. Wait, why are we shifting up? No, that's not need. We don't need that yet. It should be the tile to the right. It should be the same as this, actually. Right. I think so. It doesn't work. It's actually broken. Alright, well, I will figure out what's broken off stream. But you know, we did some stuff today, right? Isn't that cool? Isn't that a cool thing? What if it was this? Yeah, we did some stuff. Because everyone did help. We did suggest various things. I was like, that's cool. Also, I've set up a second GitHub account just to be able to push code and not have to sync through SyncThing. So, you know, normally I have SyncThing set up. I have to wait until the file synchronize over. Because I don't want to have my main Git stuff on here as I'm streaming, because, you know, what if I accidentally reveal the secret key, right? I made a second GitHub account that only has access to certain repos that I'm specifically working on stream. And then I can push code to it. But then now that I'm doing that, I have to like commit my work in progress stuff and push it so that it's there. Git commit Work in progress. Paint tiles to white. Alright, whatever. It's fine. Anyway, that's gonna be it. Good stream, good stream. Rare 3. It's not that rare. It happens, like, all the time. Alright, let's see what day it is. Oop. Alright, of these days, it's going to be a bunch of the double cheeseburger day, bro. There was a point where it didn't, well now it's common. Engineers Day. We gotta, what, Dot? You tell me to raid Dot? Butterscotch Cinnamon. Pie Day, double cheeseburger. Make a hat day. Cheese toast day. I like double cheeseburger day. Wait, let's do that one. National Double Cheeseburger Day raid. Someone can probably post a cheeseburger emoji with that one. But okay, who do I raid today? Various people are streaming. And I will raid one of these people. What is that emoji? Eggy Ka cheeseburger? That's crazy. Okay, but like Dot level is live, it's also Dot Day. I mean, like, if there was ever a day to raid Dot, Dot Day would make sense. Let me check. Dot Day, what exactly is Dot Day? Dot Day is September 15th. I mean, it makes sense, right? Do I want to raid Dot? I don't know. I just don't know. It's hard. It's hard to choose who to raid. Fair enough. I mean, I feel like we don't interact that often, though. That's the thing. It's like, I feel like nowadays I mostly raid people that I at least somewhat interact with. Okay, which one? Who here do I interact with? Scrolling. That has never stopped a raid. Yeah, but I feel like, you know, I would prefer to raid people that I do interact with. If I can. It's hard though. So true, dancer stream, see ya. They're leaving. Not even here for the raid. What if we raid someone new? What if we raid this person who I've never raided? Never raided before. They're also playing a Game Boy game. They're playing Wario Land 2, which is Game Boy. I was doing Game Boy development. That's like related, right? Anyway, the raid's going. I'll be back on Wednesday. I did say that I would not be streaming on Wednesday, but I forgot. That's actually next week. I thought the work event was going to be this week, but actually it's next week. So I will be streaming Wednesday. It'll be either like web fishing or more game dev. You're like, what the web fishing? Return of web fishing? That's right, web fishing, it's back. It's a game that no one plays. She's on my following list, not to brag. Well, she's also on my following list. Because ChocoJax rated her some days ago. And I was like, that's cool. It's because I played on a back stream? Yes, because I'm like, man, web fishing is fun. What a fun game. This would make sense then? Yeah, because ChocoJax rated. It makes a lot of sense. And now I'm going to sit here for several seconds. Okay, raid's going. Thanks for watching. Goodbye.